There are a lot of theories in physics where there's no experimental data. Now, you think how weird that is. String theory, which is the current idea, at least by some, of a way of unifying all the different forces together. But there's no experimental data to say that the 10-dimensional thing works. So I'm going to back off of theories that don't have any experimental data. And I'm also going to emphasize the experiments, like the neutrino thing, the experiments that say there's an existence of a neutrino. Because remember, Fermi said and Wolfgang Pauli said there was a neutrino, and they coined the phrase, but they didn't have any experimental data other than just a rough idea that the spectrum was continuous rather than a spike. So that was very loose information about the neutrino, and I'm not so sure a neutrino is that obvious now. But let's talk about some things that are have really good experimental data. Let's talk about Newton. Good old Newton. His laws of motion, where's the experimental data come from? The experimental data comes from Galileo. So Galileo collected the data, he just didn't have the math to come up with the theory of the laws of motion. What about gravity? Well, this one's really strange. Is that gravity, the experimental data was collected by Tycho Brahe. And then from Tycho Brahe, Kepler came up with the ideas of planetary motion. And then from the planetary motion, Newton developed his theory of gravity. But could we measure the gravitational force or the gravitational constant? No, that came later, and Cavendish came up with that. How about Maxwell's equations? Maxwell's equations, well, they are very difficult to decipher. But the experimental, at least he had experimental data that he was going on. He had experimental data from Alessandro Volta that came up with the battery concept. So Volta built these batteries and showed that there were differences in the different kinds of metal that he used to create these. Uh, who else is involved? Well, we have Ampere. I think you get the idea. So I have been a person with a bachelor's in physics, and I was trying to proceed into the theoretical domain. But as from feedback from one of my viewers, from one of my loyal viewers, they indicated that maybe I'm jamming too hard on the math. And the math is going to take me years and years before I grind through the math so then I can look at the theories and justify the theories. Well, guess what? I did a little research, and an experimental physicist only requires a bachelor's degree. And what's the next thing is, well, he has to have all this apparatus, which can be super expensive to perform these experiments. But where does that come from? Well, there's government grants and various things that universities and places of high research do that. And then the experimental physicists come up with the ideas and how to build these things. So that's really where I'm headed. So let's not focus on theories where there's very little experimental evidence. Einstein, for example, where's the experimental evidence? Well, he used thought experiments for most of his ideas, not measurements, not data, but thought experiments to come up with his ideas for relativity. And it was just a experiment by Michelson Morley that showed that maybe the speed of light doesn't depend on what it's passing through. And we can go through that in more detail. I can do a more detailed video on that. But Einstein was a theoretical physicist. He didn't work in the lab. He didn't design experiments. He just used a bunch of math based on Maxwell's equations and came up with some of these other things that he did. So let's keep that in mind and not get all hung up on the dogma that can come from theoretical physicists. We have to go back and check, well, to find out what the truth is, let's see what the data says. Without data, without numbers, you really don't have much science. So let's focus on that. I hope this short little intro will get you fired up and want to talk about the experiments for physics.